Good morning, everyone. We will begin very shortly with the webinar. We'll just let people kind of come in, and once that number gets up, we'll start. Okay, so that looks like a steady amount of people have come in now. So let's begin. First of all, welcome to everyone to today's webinar on engineering bill of material management in Windchill PLM. I'm Deepan Revalia, you can call me D, and I'll be taking you through a deep dive into how transitioning from a CAD-centric to a part-centric approach can optimize your product development lifecycle. So this is session number 2 of 6 in the series, each extending from the previous one. So the first one was just looking at the beginning of moving from PDM to PLM. Now we're going to be focusing on bill of materials, or the EBOM, and then the next one will extend on this by advancing the part-centric approach to your BOM. And then we move on to change management and configuration management and all those other juicy topics. So I can sense we have a technical audience today, so we won't be covering the basics of Windchill PLM. Instead, we'll focus on advanced insights, best practices, and real-world implementation strategies that can help your organization improve EBOM management at scale. So let's take a look at our agenda for today. We're going to have some deep technical insights into EBOM structures within Windchill PLM, how EBOM integrates with advanced PLM functionalities, including configuration management, change control, and downstream processes, challenges and solutions for transitioning from CAD-centric to part-centric EBOMs, and then some live Q&A to address any specific technical challenges. Okay, so let's get started. Understanding engineering bill of materials, or the EBOM, in Windchill PLM. Now let's start by defining the engineering bill of materials in the context of Windchill PLM and how it differs from other BOM structures. So, the technical definition of EBOM in Windchill. An EBOM in Windchill is a structured representation of the product as designed by engineers, typically created within CAD systems like Creo, but not limited to. We have third-party CAD systems, Inventor, SolidWorks, and they are integrated into Windchill via PDM link. The EBOM contains engineering relevant parts, assemblies, and sub-assemblies, along with the metadata, such as things like material properties, tolerances, and compliance attributes. Now, unlike a manufacturing BOM or an MBOM, which is structured for production processes, the EBOM is purely engineering driven and maintained within Windchill's product structure browser. So it serves as the foundation for downstream activities such as configuration control, change management, and enterprise-wide collaboration. Now, how Windchill manages EBOM data. Windchill PLM stores EBOM data in an object-oriented architecture where each component is assigned a part number, revision, lifecycle state, and version history. The platform supports both single-level EBOMs for simple products and multi-level EBOMs for complex, highly configurable products. As you guys are well aware, version control and lifecycle states are critical in managing EBOMs within Windchill PDM Link because they ensure data accuracy, maintain traceability, and enforce process control. Additionally, Windchill allows organizations to define usage, units, substitute parts, and alternate parts, ensuring that the right part is used in the right configuration at any given time. Okay, so what we're going to do is we're going to start off by showing you the creation of those parts and how that BOM structure is made. And I'm going to do this from CAD. So here I have a brand new assembly within Creo that has not been checked in to Windchill. And as you guys are well aware, I can do a quick check-in using the auto function or a custom check-in if I want to have a bit more control over the settings before the information is saved into the system. For the time being, however, I'm just going to perform the auto check-in. And what that's going to do in the background, that will save the assembly into Windchill, and it will also create the part structure or the product structure. And whilst it's doing that in the background, I'm going to open up the web browser and show you my product within Windchill. And as we can see here, currently I have nothing in my BOM folder, and this is where Windchill will create that part structure for us. And we are just having some difficulties with Creo, as you do. There we go. Apologies for this. Let me just correct this issue. We have an import with something that already exists in Windchill. And I just need to rename that part. And we'll try again with the check-in. Apologies for this. And I'm just going to try and resolve the naming issue we have. And third time's a charm. Okay. It wouldn't be a wind chill demonstration without some real life struggles. Okay, so there we go. Now that new CAD model, which is our motor pump, has been checked into the system. And what we can see here is Windchill has now created our Windchill parts, or WT parts as they're known as, and they are in our workspace. So this was automatically done by the system. We did not have to do anything. And now if we take a look at our product, we can see there's our part structure. We have our CAD also checked in, as you would expect. So the next thing I'm going to do is I'm going to take a look at the information about our part structure. So we'll have a look at the motor assembly. And you guys, I'm sure, are familiar with the various tabs. The one that we are interested in is the structure tab. This is where we have the ability to see our EBOM structure on the left-hand side with all of the important information such as the number, the state, things like version, revision, the primary attributes. Now, of course, we can control all of this using Windchill views. I'm just going to take you through the different tabs that we have here. So all of our primary attributes shown here in the first tab. If we have classification enabled, we can see all the classification attributes. I only have a custom attribute created, which you can see at the bottom. However, if we have parts link enabled and configured in Windchill, then we will be able to see all of those part classifications and groupings here as well. The visualization tab shows us a representation of the model. And of course, this is a dynamic representation. So whatever I select from my visualization, it will highlight that in the structure tab. And vice versa. If I select something from the structure tab, it will also highlight that inside the visualization, which gives useful and effective feedback. We then have the uses tab, which tells us which parts are used within the structure that we have selected or the part that we've selected. And then we have usage information as well, quantities, units, trace code. And all of this, of course, can be manipulated from the web browser. We don't need a third-party tool to do anything or another applet. Everything can be done from within our web browser. And then any occurrences that we have for the part that we've selected will be shown in the occurrences tab. If we have any effectivities against the part, then they will be shown here. And then if this part is superseded by another one, and any related documents. So useful information from those tabs at the top there. Next, let's take a look at the reporting and structure tab functionality as well. So we have the ability to insert existing or insert new parts into the structure easily. We can also edit that structure as well and edit the part or rename it. Various data management functions such as check-in and check-out can be done here. We have a copy and paste, which sounds rudimental and simple. However, this actually becomes something quite powerful when you're looking into configuration management as we can copy bombs or part bombs from one structure into another. And that's something I will show you a little bit later on. Now, I touched on this before, but we have the ability to interrogate this structure by expanding, selecting all. We can create different views. Currently, I'm looking at my EBOM view, which shows attributes or columns such as number, state, quantity, the trace code, reference designator. However, again, as you guys are well aware, you have the ability to control what you see, and then that subsequently affects things like the reporting functionality. We can also create new promotion requests, part configurations from within here, and we can add this structure to things like a baseline or project or workspaces. Next, we have the filter options. Now, the filter options, again, are another powerful tool which can be used for configuration management to show different configurations of this EBOM. And that's something I'll go through a little bit later on. We have comparison tools to compare bombs and parts. And we can also open these up in our bomb transformer if we have npm link, or in CreoView as well, if we want to take a look and we're more familiar with visualization through this tool instead. And then finally, we have various out-of-the-box reports that we can use. So I'll just go through some of these that I use mostly. Things like the multi-level bomb, which essentially is a flat file of all of the list of parts. Multi-level components list, sorry. And then we have the multi-level bomb, which is an indented structure of the bill of materials. And of course, again, all this information here can be exported. We can also change the information that we want to export by using Windchill views again. Simple, familiar, but powerful. Then from here, we can export this to a useful file type, normally something like a CSV. I'll just show you what that looks like. And this, of course, can be used for reporting. We can manipulate the data to suit the business needs. Okay, so this is just some simple navigation of how to get around looking at information about bombs. Okay, so now that we've gone through this, we need to talk about things like end items. What is an end item? This is a deliverable product or an end product that you deliver to the customer. So what we can do is we can assign parts in our BOM as an end item. Now this is used for information, but it also has other uses. You can see now that the top level motor has a diamond icon next to it to represent it as an end item. And if we take a look at the product, the motor pump product, under the details, we will now see that our end item is part of that because it represents the product. This is one use. The other use is through the change process, as you will be able to see the affected end items for something that you are about to make a change to. Okay, and this works through the impact analysis of the change and allows you to make better decisions downstream. Okay, so we've imported a BOM structure using CAD. How about the other way around? We can also import that structure, first of all. Now, instead of manually creating this, what we can do is we can use a spreadsheet. And if we have a look at the export functionality, you can see that we have the ability to export an importable spreadsheet. And if we do this, we have options to include the parts only, the BOM, any replacements or specific documents. If I were to select just the parts, then I would get a list of all of the parts that I could now import into Windchill and create. So instead of having to manually do this, we can do this through the Excel spreadsheet. And I'm going to show you what that looks like. So here I have an example of a list of parts, or it's the same motor assembly. And what we can do is we can manipulate this easily in order to import into Windchill and for Windchill to create that part structure for us. Okay, so I'm going to go ahead and I'm going to go and show you how we do this. So within the product, I can import from spreadsheet, and I can select my importable spreadsheet, which will be the motor import. And the first thing I'll do is I'll get Windchill to validate and make sure that it's okay. Everything looks good. The preview will just basically give me the top level to make sure that it's the correct one that I'm trying to import, which is that motor. And before I do this, this is where I'm importing it to. So as we can see from the spreadsheet, we have the location of where we want this EBOM to go. So I'm going to go ahead with the import. And as you can see now, I've refreshed the page, and here we have our part list, or the parts created within Windchill. Now, just because we've created the parts, we haven't actually done anything to the structure. So if we take a look at the top level, motor assembly, structure, we can see there is nothing underneath. So by exporting the BOM, we are now able to create and manipulate the structure. So again, doing it the same thing as before and importing from spreadsheet. This time, I'm going to import the structure itself, go through the same process, validate, and this time I'm going to import. Now let's take a look at that structure again. Yeah, took a second, but there we go. And as you can see, we have our EBOM within that structure now. All of the relationships and links to those parts, all through that Excel spreadsheet. This can save a lot of time for anyone doing their configuration management, as downstream applications and systems have the ability to export information into an Excel or a CSV, and then this can easily be manipulated into the correct format for Windchill to absorb and create that structure and those parts. Now, once we have this structure, again, we can manipulate and add or take away from it using the simple functions within the tool here. So I may want to create a brand new part, and this could be a material, maybe some paint or some glue. So let's go ahead and do that. And as you can see there, it's now been put into the structure. And I can do this as efficiently as I want. You know, there may be multiple parts. I can select that. Once I am done manipulating this BOM, I can then save it back in again. So I mentioned before about the powerful capabilities of BOM manipulation. And this time what I'm going to do is I'm going to create a standalone part, which is going to be my second motor pump. Oh, let's just make that an end item. Go. And now what I can do is I can select any part of the structure that I want, and I will copy this. There you go. And if I take a look at the structure of my new motor part, I can now hit the paste. And what that's done is that's automatically checked it out because it knows I want to try and change the digital definition of that part. And then it has added my lower level components in. So very simple to do. And this is very easy EBOM manipulation. And at a user end, everything is done from a web browser. I can then check the structure in and then continue on the maturity of this EBOM through its life cycle. Okay, so the next thing I want to show is how we can associate our BOMs to the CAD in a manual way. We have done it through the automation of Windchill doing this. So I'll go ahead and create a new part. And we can go and check this in. Okay, so this has automatically created our part. Now we will go through the manual method. And we're going to go through with a custom check-in because I don't want Windchill to create the part. Okay, but what I do want to do is I will create the part myself. So I will go ahead and create the part, and then let's check this one in as well. And then from within our workspace, we have the ability to edit the associations manually. So I'm going to go ahead and do that. And there we can see in the table, I would like to connect this part to my CAD. And we have the ability to define the type of association, whether it's a primary type of association, which is the owner link, whether it's a secondary type of association, if it's a reference, such as a drawing or a representation, then it can be an image or a content. So I'm going to keep this as the owner. And then once I've done that, I'm going to check in the part. I'll just quickly show you first of all. If I go to related objects, we can see now that it's been associated. And I can go ahead and check that in. Okay, so we've successfully manually associated a part to CAD. So instead of doing the bottom down approach, we've done it the other way. Okay, so we spoke about this owner association just a second ago. The next thing I'd like to show you is what that owner association actually does in the background. So I'm going to create a new part. And this time I'm going to add a parameter. And we'll designate this. Okay. Now I'll go and let Windchill create my part. We're going to check that in. Let's take a look at the information. Now we can see here, there is our attribute with the value that I input. I'm going to go to the related WT part, and you'll also notice now that it has copied over and propagated the value of that attribute. This provides us an ability to update information without having to do it multiple times. We can simply update the CAD part, which will then update the subsequent WT part as well. Okay. And of course, this is going to be used for our downstream systems when we do things like ERP integration, and we can use that information. And instead of having to duplicate it, we just type it and input it once. Okay, cool. So let's speak about the role of EBOM in PLM modernization. As organizations transition from PDM to full-scale PLM, EBOM management within Windchill becomes a central function. Here's how Windchill PLM enhances EBOM workflows and data integrity. So EBOM and configuration management in Windchill. Configuration management is a core strength of Windchill PLM. The system provides robust configuration rules, allows users to manage effectivity-based BOMs by things like serial number or date-based configurations, variant BOMs leveraging Windchill platform structures functionality to create modular product structures, end item BOMs, which is something we spoke about, for managing final product assemblies with different regional or customer specific variations. So by employing these advanced configuration management features, organizations can reduce design duplication, streamline engineering change orders, or ECOs as you know them, and maintain compliance with regulatory requirements. So EBOM and change management, ECNs, ECRs. Windchill's change management module allows for structured EBOM revisions via ECNs, which is the formal change approvals that propagate updates across product structures, ECRs, or engineering change requests, which capture the proposed design changes before formal approval, and then we have deviations and waivers, which is a process to capture a departure from the design part, and this can be fed into the change process. So you're probably familiar, but a deviation is a change before the build has started, and a waiver is a change during or after the build of the engineering definition. So by integrating EBOMs into windshield change management, organizations can enforce revision control, audit trails, and automated notifications, ensuring that every change is properly reviewed and implemented without disrupting production. So I'm not going to go too much into the whole change process because that is something that is set for one of the other webinars, and I'm sure you're very much looking forward to that. So I will leave that to them. However, I do want to show you how we can see things like effectivity and where that is shown within the change notice. So I have a change against my motor assembly here that I've set up that is currently undergoing. Now we can see that by going to the Changes tab. And then if I take a look at the change notice implementation plan, I'll quickly show you what information is relevant. We can see here that we have some instructions here. If it's on order, then these items should be returned, reworked, scrapped. If it's work in process, then it gives you the instructions on what should happen. And then if it's been finished with and not used, then it should be scrapped, retrofitted, repaired. So we have the ability to use this information and process and give this downstream. And then from our resulting objects, we have the ability to manipulate and control the effectivity, as you can see here. And I can show you by looking at the effectivity information. So you can see here, this effectivity is based on date using a range. However, it can be done on lot, serial number, those types of things. And then again, familiar interface for you guys on how to actually manipulate and set the effectivity. And then we spoke about deviations and waivers and how they are used in Windchill with the EBOM. And this is done through the interface, creating a new variance. And if you're familiar with change in Windchill, then you'll be familiar with the form setup for deviations and waivers. Okay, whether it's a major or a minor, whether it's recurring, there's certain bits of information that you need to fill in. How many is the approved quantity? The impact, corrective action, effects on cost. So filling in various bits of information. The end item, which I said is important because this helps us to see how this change affects or this deviation affects the end product or the deliverable. And then any other affected objects, attachments, brochure, it could be an image from a customer or a website link. And then finally, we have the ability to associate other process objects such as changes, problem reports, and any other referenced objects, documents, and things like that. This all ties in, going back to our EBOM. Okay. So challenges with CAD-centric versus part-centric approach in EBOM. So the first thing is the gap in intelligence. As you're limited by what you can see, since you are focusing solely on mechanical components, while part-centric methods integrate crucial engineering, manufacturing, and supply chain data for better decision-making. So you can think of the analogy of X-ray versus full medical scan, okay? One gives you the ability to have a sight into everything, whereas the other one is quite limited. And part-centric integrates engineering specs, manufacturing data, supplier info, costs, all those variables and factors, and enables data-driven decisions across entire product life cycles. Okay. Then we have complete product definition. So CAD-centric EBOMs, they miss things that are critical. Non-CAD elements like electronics, software, consumables, and this can create incomplete product definitions. Whereas a part-centric approach captures all of the elements for complete visibility. In this day and age, as you know, modern products, they include mechanical, electrical, software, different consumables. And the CAD can miss all of this. It can miss the firmware, it can miss the electronics, packaging, compliance documentation, whereas the part-centric captures all of those components. And this gives us a true product representation. Design efficiency. So building EBOM structures before CAD modeling, this allows us to have strategic planning and design alignment, unlike CAD-centric methods that create structures retroactively, and that does reduce design efficiency. Okay, the principle you can think of is blueprint before building. If you have everything set up prior, then you're able to strategize and plan better. Front-loaded planning reduces costly late-stage changes, which I'm sure you have all encountered. And this enables parallel work streams and a better team collaboration. Okay, so the benefits of part-centric approach in Windchill PLM. So a CAD-centric EBOM can be limiting as it primarily focuses on mechanical components without addressing non-CAD elements such as software, electrical systems, or compliance documentation. However, a part-centric approach in Windchill PLM provides the following advantages. Multidisciplinary data integration. So by shifting to a part-centric approach, organizations can integrate multiple data domains within Windchill, including non-drawn parts, including items such as consumables, which is paint, oil, those types of things. And I showed you in the example how we can do that quite easily. Software bombs, which is managing firmware, embedded software, and digital components. Electrical bombs, connecting PCB designs. And you can use tools like Creo schematics or Mentor graphics to the mechanical bomb. And then regulatory and compliance data, associating ROSH, REACH, your ITAR documentation directly to the bomb structure. Now, what does this look like in Windchill PLM? Let's have a look at our motor assembly. So we've seen what a structure can look like. Now let's take a look at a more complete structure. So if I expand that product structure, I can now expose all of the related documentation to it. And what we can see in here is not only the part structure, but different types of documentation, test certificates. We have replacement or substitute parts shown in the structure. And as you can see, this is now our complete product, not just a part list or a set of information documents. And we're bringing all that information in. And this becomes very powerful because now we have the ability to easily access all product information, report on this information, and of course, manipulate and collaborate. And of course, we can communicate this information to the business, to the different departments, to our downstream systems, ERP. But EBOM is the beginning for that. Okay. So, improved enterprise collaboration. A part-centric EBOM structure in Windchill will enable cross-functional collaboration between design, manufacturing, and procurement teams by ensuring that all product data is accessible through Windchill's role-based control, RBAC. We have advanced BOM querying and reporting. So Windchill's BOM query builder allows organizations to extract insights from part-centric EBOMs by generating reports on where used analysis, identifying all assemblies that use a specific part, effectivity-based reporting, which is understanding which configurations are active for a given time period. Now, this is obviously crucial when it comes to configuration management. And what I want to just show you is how that looks inside Windchill PLM. So going back to our motor assembly, I touched on the filters here. And what we can see is we have our different types of filters that we can select. Now, by default, we can see we have the latest filter. We have the ability to control the different views of those parts, design or manufacturing view. We have different BOM types, alternate BOMs. We can control and see which states. So we may have a released BOM over an in-work BOM. We can also configure the as matured BOM. So we can see when the BOM was matured at a specific time and date. We can base our filters on baselines. A baseline, as you know, is a snapshot of that configuration at a particular time. So this could be something that you have on specific releases for a customer. There may be 6 different variables or variances of that BOM. These were all captured in a baseline, and you can easily switch between those configurations by using our filter. We can base our filter on change note. So this BOM may have gone through various changes along its life cycle, and we can select the change note that corresponds to the change or configuration that we are looking for. And then effectivity based on date. So as we saw in our change note previously, it may be a range that we're looking for a specific configuration. And then we can also base this filter on promotion requests. So for configuration management, this is the crucial point. And this is where we have the ability to control what we see and what we can do with that information and that product structure or that EBOM. Okay, so let's talk about implementation strategy, transitioning to a part-centric EBOM in Windchill. So successfully transitioning from a CAD-centric to a part-centric EBOM model in Windchill requires the following approach. Here's how to execute it effectively. First of all, define a part classification system. Now, you can do this either using out-of-the-box Windchill attributes, and I showed you that in the classification tab. We only had the single attribute, which was EBOM. However, we can also utilize preferably Windchill part classification or parts link to create a grouping that categorizes parts based on attributes such as material type, function, supplier. We then automate BOM synchronization. So we use Windchill's CAD data management capabilities to establish automatic WT part CAD association, ensuring that the CAD models update the EBOM in real time. And again, this is what I showed you when I checked in our new motor pump assembly at the beginning. And when I updated the attribute EBOM, that also in turn updated automatically the relevant information in the Windchill part. We then implement a flexible EBOM strategy. So organizations can maintain a dual CAD-driven and part-driven EBOM structure within Windchill, meaning top-down or bottom-up processes. And then finally, train teams on adoption of EBOM. So this ensures that engineering teams understand how to leverage Windchill's EBOM and process features to utilize the system's full PLM capabilities. Now, expanding on from the PLM solutions beyond EBOM management. So implementing effective EBOM management will help to facilitate further PLM advancements. This will include things like supplier and manufacturer management, or SUMA as it's known, which ensures accurate supplier part data integration with EBOM for better sourcing and procurement decisions are made. CAPA, corrective and preventative actions, enables tracking and resolution of quality issues by linking the EBOM components to CAPA processes. We have the customer experience, which enhances after-sales support by maintaining accurate BOMs for service and spare parts management. We spoke about configuration management, which maintains the consistency across product variations by controlling design changes and ensuring alignment between engineering, manufacturing, and service teams. Then you can have a look at MPM Link, which is manufacturing process management, which connects the EBOMs to the MBOMs for seamless product or production planning. And then ERP integration, the Holy Grail, which ensures synchronization data flow between PLM and ERP systems for streamlined supply chain and production operations. So you can see here that EBOM management serves as a foundation for broader PLM adoption. Hopefully you have some good examples of the capabilities from the demonstrations. And this here moves nicely on to what we will be learning in some of the other series that are approaching. And it kind of gives you an insight into how all of this is connected and how we move along our journey of PLM. So don't miss out on advanced part-centric approaches for your bill of materials. Okay, so that brings us to the end of the presentation. I'd love to open up the floor to any questions you may have regarding Windchill's PLM EBOM capabilities. If you have any specific implementation challenges, data migration concerns, or need best practices for optimizing your Windchill setup, feel free to ask. Thanks for joining today's webinar. We hope this session has provided any valuable insights that you can apply within your organization. Thanks, guys.